In the last video, we started factoring polynomials. Today, we're going to focus on a particular type of polynomial called a quadratic, and we're going to factor them apart. So previously, what we learned about multiplying out was that we used the FOIL method. We go through first, outer, inner, and the last terms. We'd combine our like terms, and we'd get this polynomial that says 5x squared plus 11x plus 2. But we were going in this particular fashion where we take our parentheses, multiply it out, combine to get our final answer. Now our job with factoring is to go backwards with that. We're going to take the answer and we're going to work backwards to get these two parentheses. So that's what factoring is for a quadratic. Now, we're going to use this method called the AC method for factoring. First off, standard form of a quadratic. A quadratic, the word quadratic means that our highest degree or our exponent in this is going to be a 2, where a quadratic form has 3 terms. Now, the steps that we're going to use for this AC method is, if necessary, we have to get into the habit of looking at each term and seeing if they have any common factors, anything that goes into each 3 pieces. If you need to do that, or if you don't need to do that, we're going to move down to step 2. It says multiply A and C. So what that means, the number that's in the A spot of the quadratic and the number that's in the C, or the constant part of the quadratic, we're going to multiply those together to get a number. Step 3, it says find the factors of AC. So whatever number we get after multiplying AC, we're going to find factors of them that if I add them up, I get the middle number B. Step 4, once I find those two numbers, I'm going to replace B with the two factors and then I'm going to complete the problem with factor by grouping. So let's see what happens here. So step 1, if necessary, factor out any common factors. I look at x squared, 9x, and 20, and other than the number 1, there are no common factors out of this. So I don't need to worry about the step. I'm going to move on down to step 2. Step 2, multiply A and C. Now, A is the number in front of x squared, and you don't see a number, so that means that it's a 1. So I'm going to take 1 times 20. So I've got 20 from my multiplication. Step 3, find factors of A and C that add up to get B. Now, the number that's in the B position is 9. So whatever factors I get of 20, they have to add up to give me the number 9. So I'm looking for two numbers to multiply to give me 20, that at the same time, if I add them up, I'm going to get 9. And I'm just going to start listing out multiples of 20. The easiest multiple, or not multiples, but the factors of 20. The easiest factors that I can think of are 1 and 20, because 1 times 20 is 20. Now, if I add 1 and 20 together, I get 21, and that's not 9. So I'm going to go in and find some more factors of 20. 2 times 10 multiplies to give me 20, but 2 plus 10 gives me 12, not 9. I'm closer, but it's not exactly 9. So let's try another one. 4 times 5 is 20, but look there. 4 plus 5 is 9. That satisfied what I'm looking for. So these are the two numbers that I'm going to use. So step 4, replace B. So I'm going to take out the number 9, and I'm going to replace it with a 4x plus 5x. Okay. Now, if you see there, if I were to combine those terms back together, 4 plus 5 gives us 9. So I'm breaking this apart. And I'm going to use factor by grouping. So I look at my first two terms, x squared and a 4x. What they have, at most they have in common is an x. And if I look at 5x and 20, what they have in common at most is a 5. So I factor the x out of the x squared plus 4. I have an x plus 4 remaining. I factor the 5 out of the 5x plus 20. There's the other x plus 4 that's remaining. I factor out the parenthesis. I group up the x and the 5. And I have x plus 5 times x plus 4. This is the factored form of the polynomial x squared plus 9x plus 20. So let's go through another one. I go through step 1 and I look at 7x squared, 29x, and positive 4. Other than the number 1, not all 3 of these terms have the greatest common factor. So I'm going to go on to step 2, and I'm going to multiply the A and the C. This time I have a number that's greater than 1, so 7, my A, times 4, my C number, is 28. I'm going to be looking for two numbers that multiply to give me 28, that at the same time, they're going to add to give me that middle number of 29. The first two factors that I list out are 1 and 28, because 1 times 28 is 28. But right away, immediately, 1 plus 28 is 29. So there's the two numbers that I'm looking for. I replace that 29 with an x plus 28x, because that's 1x plus 28x to give me the 29x. And I go through and factor by grouping. 7x squared and plus x. I group up the 28x and the plus 4. You see that 7x squared and an x have an x in common. I factor out the x and I have 7x plus 1 remaining. 28x plus 4, they have a 4 in common. I factor it out. And again, my parentheses are supposed to match up when I do grouping, so I have another 7x plus 1. And I group up the pieces that are on the outside and write one copy of the 7x plus 1, and there's the factored form of this polynomial. X plus 4 times 7x plus 1. And again, like I mentioned back whenever we first started factor by grouping, that if you're not sure if you factored it correctly, FOIL the problem back out and you should always get what you started with. Now here's another trinomial. The one thing that's different between this trinomial and the one that we had previously is that it's not in a standard form, and you have to make sure that your quadratic is in a standard form. So I'm going to rearrange this so that my exponents go down in descending order. Got x squared plus 22x minus 8. So now that it's in a standard form, and I go through and I look at all three pieces, and one thing I do notice is that 6, 22, and negative 8, they're all even numbers, so I know that they have a common factor in there, and I want to find the largest number that goes into all three of them, and that is a 2. So I put the 2 on the outside, and I say, what do I have left over? Well, 6 divided by 2 gives us 3, so I got 3x squared. 22 divided by 2 gives us 11, so I got 11x. Negative 8 divided by 2 is negative 4. Now, the part that I'm going to focus on is what's inside of the parentheses. That's the part that I want to do the AC method on. So my A in this time, or this particular problem, is a 3. The C is going to be the negative 4. So 3 times negative 4 is negative 12. I'm looking for two factors of negative 12 that are going to add up to give me positive 11. So I'm going to start listing out my factors. I'm going to list out the easiest one, 1 and negative 12. When I add 1 and negative 12, I get negative 11. And I'm looking for positive 11. So I got the wrong sign. So I'm going to list out another one. 2 times negative 6. Combine those up, you get negative 4. 3 and negative 4. Add those up, you get negative 1. Now, none of those gave me positive 11, but the nice thing about this is that whether I do a positive times a negative, I can do a negative times a positive, I still get the negative product. But what if I flip the signs around? Negative 1 times 12 is still the negative 12 that I'm looking for, but in this case, negative 1 plus 12 gives me the positive 11. So those are the two numbers that I'm going to use. I replace the 11x with a negative x plus 12, and I factor by grouping here. I group up the first two terms, 3x squared minus x, and the 12x minus 4 I group up second. I find my greatest common factor. Between the first two terms, I have an x in common, so I have 3x minus 1 remaining. Between the 12x and the minus 4, there is a positive 4 in common, which again leaves us with our 3x minus 1. And I factor out the parentheses, and I get x plus 4 and 3x minus 1. Now, what about the 2 that I factored out at the beginning? We can't lose sight of that. So just because I had it out at the beginning, it doesn't mean I get to throw it away. I have to reintroduce it back into my answer. So the final answer here is 2 times x plus 4 times 3x minus 1. Okay. Another example, 4x squared minus 3x plus 5. I've got it at a standard form. I'm going to go through and look and see, does each term have any other common factors other than 1? Here I do not, so then I go to step 2. 4 times 5, my A times C. So I'm going to look for two numbers that are going to multiply to give me 20 that add to give me negative 3. I start listing out factors. 1 and 20. When I add them, I get positive 21, so I need to search again. 2 and 10, that gives me 12. I'm getting closer, but it's not negative yet. 4 and 5, we get 9 when we add them. Again, those are all positive numbers. But one thing that you want to think about is, remember how a negative times a negative equals positive? So let's go in and try some of those combinations. Negative 1 times negative 20 does give us 20. Add them up. I'm still not negative 3. I'm at negative 21. Negative 2 and negative 10 gives us negative 20. Or sorry, positive 20. Combine those up, I get negative 12. Again, that's not negative 3. And then we have negative 4 and negative 5. Combine those, you get negative 9. So I've just listed out all these possibilities, and I've not been able to find a combination that gives me negative 3. So in this case, 4x squared minus 3x plus 5 is considered, here's a vocab word, prime. Just like prime numbers, where their only factors are 1 and itself, polynomials can behave the same way. The only factors of this particular polynomial is just the number 1 and the entire polynomial itself. So there are polynomials out there that are not factorable, and we call them prime, just like